Before we look at the concept of multi-user MIMO, we first need to start by defining what MIMO is. MIMO, which stands for Multiple Input, Multiple Output, is in a range of technologies used to multiply the capacity of a wireless connection without requiring additional spectrum by using the horizontal and vertical polarities of the radio wave, each carrying a separate data stream to transmit and receive data. Because the two polarities are perpendicular to each other, there is a separation, or isolation, that helps prevent them from interfering with each other. For example, think about when you attend a web meeting. Information is being transmitted and received by your ears as you listen to the person talk, and by your eyes as you view the screen. The two transmissions are separated or isolated because one is carried by light waves while the other is carried by sound waves. While MIMO doubles the network capacity by using the horizontal and vertical polarity of a radio wave, the number of transmitting antennas must equal the number of receiving antennas at any moment. This makes scaling challenging. This is where MU-MIMO comes in. MU-MIMO, which stands for Multi-User MIMO, isolates the traffic of each subscriber, allowing them to transmit and receive concurrently between multiple subscribers. Where there was once one beam, we now have 7 beams. When we separate or isolate the traffic for each subscriber, we use a concept called beamforming. In this process, the antenna array is focused and tuned to target a particular subscriber. In this animation, the red beam is targeting the red subscriber. Now let's take a look at a short animation about the improved performance of this beamforming technology.
The access point forms a narrow beam which has high gain in a specific direction, rather than across the wide angle used in conventional systems. This narrow beam points towards the subscriber the access point wants to receive data from, intersecting with the subscriber's beam and receiving its data, whilst at the same time mitigating interference from interferers. As the access point wants to listen to other subscribers, the beam from the access point is formed in a direction pointing towards the subscriber of interest, again mitigating interference from interferers. This can provide a higher signal level to the subscriber, improving network performance as the signal energy is narrowly focused as opposed to the wide beam in a conventional system.
The goal of beamforming is to allow as many concurrent transmissions possible on the same wireless spectrum by using spatially separated radio beams. As you can see, each beam is targeting a specific subscriber is much narrower than the normal beam from the AP, enabling multiple beams to be used concurrently without any interference. But how does the beam know which subscriber is which? If there are a lot of subscribers in the area, wouldn't it get confused? This is where channel sounding comes in. The radios are always talking, but how does the base station know which subscriber is actually doing the talking? Channel state information, known as CSI, enables the base station to be able to distinguish between subscribers. And while it is not unique, you can think of each subscriber as having its own fingerprint that the base station uses for identification. But wait, does having more beams really improve performance? If we look at the beam itself, because it's narrow, the areas normally covered by higher modulation are extended, increasing throughput for those at the edge of the coverage area. This allows people who used to be frustrated by their throughput to be much happier. As a result of this technology, MU-MIMO provides a large boost in sector capacity by incorporating a highly advanced signal processing, beamforming, and channel sounding techniques that gives a user a higher throughput and a better overall experience.